Hi, I'm Ken Resnick from Rath Associates. We're going to be doing combustion analysis today, and we're going to be utilizing a large wall-hung modulating condensing boiler, as well as a TPI DC710 combustion analyzer. The DC710 is a Bluetooth analyzer, so you'll be seeing that I'm going to be utilizing my cell phone as a smartphone for that Bluetooth combustion analyzer. First things first, what we're going to need to do is make sure that there's an elongated call for heat, and that call for heat to keep that boiler running while you're doing the combustion analysis. That call for heat can be a domestic hot water call or even a heating call in the wintertime, so you're not overheating the house in the summer. But anyway, make sure you're getting a nice long call for heat to go through the entire combustion procedure and combustion analysis procedure. So, following your manufacturer's instructions for your analyzer, as on ours for the TPI DC710, the manufacturer suggests that we do a pre-purge of the analyzer. That pre-purge was performed earlier outside of this boiler room, outside of this mechanical room, because we don't want to get any of the impurities from that mechanical room to go through that analyzer. Setting up the boiler to do a combustion analysis would include, dependent on the manufacturer, potentially removing the outdoor temperature sensor and raising your set limits or your set temperature limits for that boiler. Again, so that you have a nice long run cycle to be able to get the combustion analysis performed. So here what we've done is we've done the pre-purge of the analyzer. Our probe for that analyzer is in the combustion test port provided to you by the boiler manufacturer or by the manufacturer of the flue piping. Here for Lars, they provide you a small test port, and we're utilizing that now. Right now what we're doing is we're looking at its combustion procedure. And its combustion procedure, to be able to do that combustion analysis for our manufacturer, Lars, needs to be in the low fire position. So I'm going to go ahead and make that adjustment to this boiler. And for Lars, it's as easy as one dip switch flip. And that dip switch flip is going to be dip switch number 7. We're going to flip that over to the on position. And in the on position, we're now going to be firing at a very low fire. According to the manufacturer's instructions for this Lars boiler, we are now locked in a low fire. And we're going to be able to take a look at what those combustion analysis results are. Please follow your boiler manufacturer's instructions, which can usually be found in your manufacturer's I/O manual. For ease of viewing, I've attached my smartphone to a very large monitor that's above me, so all can see. We've zoomed into the monitor for ease of viewing, and now let's talk about what those numbers actually mean. On the TPI DC710 Bluetooth analyzer, I've arranged my screen so that carbon monoxide and carbon dioxide are both close to the top of my listing. Those are my two most important parameters. So as you see, we've got 2 parts per million. That's single 2 parts per million right now of carbon monoxide, and you can see the change. We are doing a live carbon monoxide, live carbon dioxide, the entire live combustion analysis for you. You can actually see where that dropped down to 0 parts per million for carbon monoxide now. Our carbon dioxide reading is showing 8.2%. According to our manufacturer, Lars, we need to be somewhere between 8 and 10%. Well, we kind of are in that parameter, but a little bit to the low side. We're going to make those adjustments in a moment. Dropping down, you'll see O2. That's your oxygen level, 6.4%. Excess air, 44%. Temperature of probe 1. Probe 1 is actually the exhaust temperature probe. That's the probe that's in our sample, in our exhaust temperature sample. And then internal temperature. Internal temperature means ambient. We're in a room right now that's 81.3 degrees Fahrenheit. According to manufacturer's instructions, which of course can be found in your I/O manual of any manufacturer that you're working on, we're going to need to go ahead and adjust that gas valve. What we're going to be doing is increasing the CO2 value by increasing gas pressure slightly. So here on the Lars unit, we're going to be taking a tool and putting that inside of what we call the incline adjustment, or the gas pressure adjustment right inside of the gas valve. According to the manufacturer's instructions, we're going to increase the CO2 by turning our tool slightly clockwise. All of that information is found in the I/O manual, online, and also, for Lars, stamped right on the gas valve. So we're going to go ahead and make that adjustment. But I do warn you, very small amounts of adjustment each time. Do not give in to the temptation to go haphazard, willy-nilly. You're going to make adjustments even harder to make. So go very slightly. I'm going to go ahead and make that adjustment now, increasing CO2 by increasing gas pressure just very slightly. After making that very easy and slight adjustment to the gas valve, you can see our carbon dioxide, which is the number that this manufacturer wants you to abide by. They want you to adjust to. There's our carbon dioxide of 8.9%. And that's well within the range of 8 to 10% as provided in the information for you from the manufacturer in setting up for proper combustion analysis. After dialing in your low fire carbon dioxide setup and adjustment as provided to you by the manufacturer's information, we now have to flip over to high fire. The manufacturers want you to make adjustment, especially large, want you to make that adjustment in low fire and then only test yourself in high fire. And as you saw earlier, that changeover is very easy here on this large wall-hung condensing modulating boiler. And what we're going to do is just go right back up to that dip switch. We're going to take that dip switch number 7, which was putting it in low fire. We're going to shut that off. And now we're going to move to dip switch number 6. And we're going to put that boiler into a locked-in high fire, as you'll see here. So now with the boiler in high fire and our combustion analyzer still hooked up, we're going to now go for those parameters in high fire. According to Lars, that's between 8.5 and 10.5% CO2 in high fire, and we'll make those adjustments back in low fire if we need to. Let me explain what that means. If your high fire numbers are too high, then you need to go back to low fire and lower your low. And adversely, if your high fire numbers are too low, then you're going to go back to your low fire and raise your low fire a little higher. All of that's according to the manufacturer. Check with your manufacturer's I/O installation instructions. With your adjustments now completed in low fire and in high fire, time to turn that boiler back to normal operation. And here with the large boiler, nice and easy, all we're going to do is flip those dip switches back to normal operation. After that's completed, it's time to document, but we need to document in such a way that we have reference for this. And the reference with the TPI DC710 analyzer is really kind of neat. It's real easy too. We can email, we can make a file, and we can even print. All of that information can be found in the video that we will be doing on TPI combustion analyzers. So now at this point it's time to wrap it all up. Remember to remove your flue probe, put the plug back in your flue test probe, and also turn off your analyzer. And also, at this point, be very happy that you've done a combustion analysis the proper way, ensuring that your customer will have a very long service record and be in good shape for the winter time. Thank you.